Hi, let's talk about the convergence of alternating series. First, let's be clear about what we mean. It's all about the signs of the terms. The signs strictly alternate between positive, negative, or, of course, negative, positive. Here's an example. -1 to the n plus 1 power divided by n. Let's write a couple of terms. -1 to the 1 plus 1 is -1 squared. We get 1 over 1. -1 to the 2 plus 1 power is -1. So now we have -1 over 2. -1 to the 3 plus 1 power, back to +1 over 3, and so forth. Okay, the signs alternate. Does it converge? In other words, what happens to the limit of the nth partial sum as n goes to infinity? Let's take a look at the first few sums. The first partial sum is just the first term, 1. The second partial sum decreases by 1/2, making 1/2. The third partial sum increases by 1/3. 1/2 plus 1/3 is 5/6. It increased, but it's smaller than s sub 1. The fourth partial sum decreases by 1/4. 5/6 minus 1/4 makes 7/12. This is bigger than s sub 2, which was 1/2. The fifth will increase, but only by 1/5, and then decrease by 1/6. Up, down, up, on and on in smaller and smaller moves. It seems like we might be converging to some number here. Let's take a look at a graph of the nth partial sum as a function of n. Here's a graph of the first 30 partial sums. Around the 1000th partial sum, the total is only moving up and down by about 0.001. Up and down by smaller and smaller increments. This series is converging to a value around the blue line, 0.693 plus or minus 0.001. Whoa! Remember the harmonic series? 1 plus 1/2 plus 1/3 plus ... It diverges. And now, all we do is alternate the signs, and voila! The series converges. Is this magic? Do alternating signs guarantee convergence? Here's another alternating series example. -1 to the nth power. As always, we should write a couple of terms. -1, plus 1, minus 1, on and on. The first partial sum is the first term, -1. The second partial sum is -1 plus 1 equals 0. The third, 0 plus -1 equals -1. This alternating series oscillates between -1 and 0. So it diverges. Duh. If an alternating series is going to converge, the size of the terms better get smaller. You have to add and subtract smaller and smaller amounts. Here's a third example, one with terms that get smaller. Step 1, write out a few terms. Well, -1 to the 1 plus 1 is +1 multiplied by 1 divided by 2 minus 1. The first term is 1. Next, -1 to the 2 plus 1 power is -1, and it's multiplied by 2/3. So we end up with -2/3. On and on, the sign alternates. Now we are adding and subtracting smaller and smaller amounts. Does this series converge? Let's look at the first few partial sums. S sub 1 is the first term, 1. S sub 2 is 1, subtract 2/3, that's 1/3. S sub 3 is 1/3 plus 3/5, that's 14/15. S sub 4 is 14/15 minus 4/7. That's 38/105. We're bouncing up and down. I think a picture would help. Again, let's graph the first 30 partial sums. Uh-oh. It seems to be oscillating between two different numbers. One around 0.4 and the other 0.9. That's about 1/2 apart. How about a graph of the difference between S sub n and the previous sum, S sub n minus 1? Absolute value, of course. The difference is headed toward 1/2. First order of business. We can say this alternating series oscillates between two different values, and so diverges. But wait, you saw it right away, didn't you? Because you applied the nth term test. The terms have to go to 0 whether the nth term is positive, negative, or alternating. The signs, who cares? If they don't go to 0, the series diverges. The limit of n over 2n minus 1 is 1/2, not 0. The nth term test tells us this series diverges. Moral of the story? Yes, there is a moral. Always start with the nth term test. Oh, and there's that 1/2. As n gets large, the sum goes up and down by 1/2. We have a new convergence test, the alternating series test. There are 3 conditions. First, the signs alternate back and forth, not plus plus minus, or other variations. Second, the size of each term is smaller than the one before it. No ups and downs. Third, the nth term has to go to 0. Alternating signs may not be magic. They don't guarantee convergence, but adding and subtracting sure makes it easier to converge. The harmonic series diverges. Its alternating version, same size terms, converges. By the way, if an alternating series converges, but the non-alternating version does not, like the harmonic series, it's called conditional convergence. The series only converges because of the alternating signs.